Alright guys, I promise this video will be shorter. This is dealing with what we call Newton's law of cooling. So here's what it says. The rate at which, so here's the keyword rate, so again we're going to be talking about a differential equation. The rate at which an object's temperature is changing at any given time is roughly proportional to the difference between its temperature and the temperature of the surrounding medium. So think of it as a cup of soup, and if it's left to cool by the surrounding air. Okay, well, the surrounding air temperature has an effect as far as how long it takes for the current temperature to match the surrounding temperature. So if we were to take this differential equation here, so if we were to translate this information into this differential equation, that's what we get. Now, regular T, capital T, is just the temperature of the object, and T sub S is the temperature of the surrounding area. Okay, so the solution to this differential equation, which we're not going to derive, okay, the solution to that is known as Newton's law of cooling, and here is that solution. It's something you're just going to have to commit to memory, put it on a flashcard. And there's another variable in here, T sub 0. That's the temperature when T equals 0. So this will make a lot more sense when we do our next example. Okay, so here's our only example we're going to do. And this program I'm using here does not allow me to do the degree symbol or the Celsius symbol, although I suppose I could have used a capital C. But anyway, you could save yourself some time by just using the symbols there. So anyway, we have a hard-boiled egg at 98 degrees Celsius. It's put in a pan under running 18 degrees Celsius water to cool. So try to visualize this. After 5 minutes, the egg's temperature is found to be 38 degrees Celsius. How much longer will it take for the egg to reach 20 degrees Celsius? So we can see here that we're talking about cooling and different temperatures. So we're going to, of course, use Newton's law of cooling. So this is the equation that we have to have memorized. So T minus T sub S, so it's the difference in the two temperatures, okay, equals T sub 0 minus T sub S. And then we see the familiar e raised to the negative k times t. All right, notice this time k is negative though, right? The previous video, k was positive in the equation. Here it's negative, which indicates that it's cooling, right? So let's fill in our pieces here. So we're going to keep this T in front. Now the surrounding temperature we know is 18 degrees, okay? Because we are talking about putting these eggs in a pan under 18 degrees Celsius water, okay? So that is the surrounding temperature. So that is 18, right? The eggs are being surrounded by that 18 degree water. So from there, we have our T sub 0. Now that is the temperature when we started, okay? Well, the eggs started at 98 degrees, all right? Minus, we said the surrounding temperature was 18. Then we have this E, and then we have to the minus KT. Well, just like our other problems that we saw, we need to first find K. So step one is to find K. And the way we're going to find K is we're going to use the additional information. We're told that after 5 minutes, the temperature is 38 degrees. So let's clean this up a little bit first. So notice how I just got T alone there. So now we need to find K. So in our next step here, we're going to do exactly that. So we're going to use the information that when T is 5 minutes, talking about little t, temperature is 38. So 38 is going to go in right there. And then we're going to drop in a 5 where we see our t, our little t. So go ahead and solve that equation for K. So when we clean this up and then solve for K, K is the natural log of 1/4 divided by negative 5. And again, let's keep it nice and exact. So the last part here of the question says how much longer will it take for the egg to reach 20 degrees Celsius. So this K we could then put right back in here. All right, we can substitute that in. And we're trying to figure out how much longer. So how much longer, that's really asking us to find little t. Will it take the egg to reach 20? So step two, once we have that, is to solve. And what we're looking to solve here is, if we go back to, I also could have put this in this equation right here. If we go back to this main equation, this simplified equation, we're trying to solve the equation 20 is equal to 18 plus 80 e raised to the negative. Now remember, k we said is ln of 1/4 over 5 and then times t. So we can clean this up a little bit by subtracting over that 18, and then you could divide over that 80, or you could just do this all in your calculator. You can solve this graphically, so you need to make sure you practice doing this. Don't just take my word for it. When you solve this graphically, your t value is going to be about 13.3, and we're talking about minutes, right? So after, and that certainly sounds reasonable, after about 13.3 minutes it will reach that temperature. So again, you could enter this as is and solve it graphically. In y1 you'd put 20, in y2 you'd put the whole right hand side, look to see where they intersect. Of course we're talking about time, so you would only be looking for positive values. Okay, so solve that graphically.